All right, this is the last video for this semester. Um, so this video will teach you how to complete Excel quiz number 2. And we'll be doing confidence intervals and hypothesis tests. This particular spreadsheet that I will be showing to you will be a sample of how to do it, and I will post it along with this video in Canvas so that you'll be able to complete this assignment. Now, make sure you do the assignment by yourself. Do not use a tutor. No tutor can help you with this. You need to do it yourself. This is a skill that you can develop for yourself. I think everybody in the class can do this assignment. So please do it yourself. If I catch anybody cheating, unfortunately, both people, if it's one person cheating off of another, both people will get zeros for the assignment. So please don't cheat. Just do your own work, and you should do fine. The video is designed to show you how to do everything, and again, I'll post it. You'll have all the formulas and everything. Okay. So let me share the screen with you and show you the actual spreadsheet, that sample spreadsheet that I'll be posting. All right. And this particular spreadsheet it's basically 4 different states around the country. We're listing a sample of homes, home prices, and other things here. There's the square footage of the house and number of beds, number of baths. So it's a random sample for each of these 4 states. And basically there's 120 of these altogether. But the 4 states are California, New Jersey, and Pennsylvania, and I think there's one other one here. I'm missing one. I think New York. Yes, New York. All right, those are the 4 states. Now, in this assignment, this particular sample here, I will be illustrating just with one of these states. That's New Jersey, and I'm going to show you how to do all of this with formulas, and also how to refer to cells in the Excel spreadsheet for future formulas. All right, so there are 4 things that you'll be doing on the quiz. You'll be doing a confidence interval for proportions, confidence interval for means, a hypothesis test for proportions, and a hypothesis test for means. Okay, so on the left will be the actual spreadsheet that you'll be getting. I'll be giving you another one that you'll be using, and then basically what you see to the right here is the types of calculations that I want you to do, and of course you can copy and paste all of this into the new spreadsheet and then change the formulas, change all of the the lists of numbers and everything in the spreadsheet. Obviously, there's not going to be the same number of entries as here, so you need to make your changes and then change some of the words in here because the words are referring to this particular spreadsheet, and you need to change it to the new spreadsheet. So anyway, first thing you're going to be calculating, which will be used throughout the whole spreadsheet here, is the sample size. And the sample size is really of home prices in New Jersey. Now, what I used here is a special function called COUNTIF. It's counting. And what is the if here? Well, I'm referring to all the states that are listed here in column A, all 120 entries here. And so I refer to all of those. I highlight all of those, and then comma, I'm going to ask the Excel to look for NJ in column A. And every time it sees an NJ, it's going to count that. So there are 30 of these NJs in this column here. So COUNTIF counts all the ones with NJ. Notice I put NJ in quotes. And it comes up to 30. Now, really important, do not just count and put in 30. You need to use these functions, all right? To get credit for each of these entries, you need to actually use functions, all right? So I'm showing you one right here, COUNTIF. COUNTIF will allow you to count based on some sort of contingency here, which the contingency is that it should be in New Jersey. I'm just counting the number of New Jersey lines, basically. The second one is the number of homes in New Jersey less than 500,000. Well, I'm only going to refer to the prices in column B, the prices in New Jersey. They start at B32, go to B61. And again, I'm using COUNTIF because I want to count only the ones that are less than 500,000. Now, the prices here are in thousands of dollars, so they're only listing the first three digits of the number. The last three digits aren't listed. And so, but I'm only counting ones with less than 500 or 500,000. And I put that in quotes also, and Excel knows to check the values and in B32 to B61, where the New Jersey ones are, New Jersey prices, and check for the ones that are less than 500, and we'll count those, and there's 24. Again, please do not put 24 in, you'll get 0 for that. You must use the function. Sample proportion of homes in New Jersey, less than 500,000, that's simply 24 divided by 30, but again, you need to use formulas. So you're going to say H9, which is where the 24 is, divided by H5, that's where the 30 is. That comes out to 0.8. All right, so we know the proportion is 0.8 or 80%. Now, now this will be described in the actual quiz that you get, but in this particular case, I'm going to be doing a 90% confidence interval. So if I ask you to do something different than 90%, you're going to change the word in here to 95%, change it to 0.95%, right? So all these words that are in here, make sure you change the wording that matches the problem that I give you, all right? So, you know, don't say sample size of home prices in New Jersey if I'm talking about, you know, the number of people voting for candidate A or something like that. You have to change the words in here to match the problem, all right? And also here, the confidence level you need to change in here. All right, anyway, I'm interested in this particular case in a 90% confidence interval. I'm estimating the proportion of all homes in New Jersey less than 500,000. All right, so first thing I'm going to do is calculate the critical value. And what I'm going to use is the inverse normal, which you use in a calculator. In Excel, it's norm.inv. In parentheses, you're going to put the area to the left. Now, if it's a 90% confidence interval, remember it's the middle, it's that area plus the left tail. And since it's 90% in the middle, 5% on each tail, that means 90 plus 5 is 95% to the left of the right endpoint. Okay, so that's what I'm going to put in for the area or probability. And of course, this is a standard normal or Z critical value. So I'm going to put 0, 1 for the mean and standard deviation. And you probably already knew this, that 1.645 is the Z for a 90% confidence interval. Or maybe you don't know it, but maybe you do from your homework. But I'm going to leave all the digits in there. Step 2 is to calculate the standard error. And if you remember, that's square root formula, right? So SQRT, remember you always use an equal sign before you use a function. SQRT is a square root function. And inside, I'm going to put the first one is going to be H14. That is going to be our 0.8. So you have to refer to it. Don't put 0.8 in here. Again, give you 0 credit if you just type numbers in. You have to type in, you have to point to the correct cells where these are residing. So it's H14 times 1 minus H14, or 1 minus 0.8, divided by H5. And what is H5? That's your sample size. H5, if you remember, that's with, it's right here. That's your sample size, okay? So square root of all of that comes out to about 0.073. That's your standard error. And then the margin of error is simply the multiplication of the critical value and the standard error. Multiply H23 times H26, you get the margin of error. The lower endpoint of the confidence interval is simply going to be H14, where the sample proportion is, that's 0.8, minus the margin of error, which is an H29. That's your lower endpoint. And then the upper endpoint is going to be H14. Okay, H14 plus H29. Okay, that's the sample proportion plus the margin of error. And then you're going to summarize it down here. This is important. You need to do this too. All right. You're going to actually type in the correct confidence interval. I'll tell you how many decimal places to round each endpoint to. In this case, 3 decimal places. And because this is not an actual formula in here, you're actually just typing in, and you're opening up a set of parentheses, just typing things in. It's just text, really, not a formula. And the rounding you have to do sort of in your head. All right, so do the rounding in your head, and then write down the correct answer here. Now, all the entries that we've done here will all get points. We'll all get points for all of this, and including the end result. All right. So that is how to do the confidence interval for proportion. Now for means, in this case, we're going to look at the sample mean of home prices. Okay. And how do you come up with the mean? You use the average function, equal average. And I do B32 through B61. That's where the prices are, and only the ones for New Jersey am I averaging. Now this times 1,000 is only in this particular situation here because the prices in column B are in thousands of dollars, and I want to display the full dollar amount, not just in thousands of dollars. So I'm multiplying it by 1,000. Please, if you're not dealing with that type of situation where you have to multiply by 1,000, please remove that in the actual problem that you're doing. All right, I'm only doing it in this case, so I have the actual dollar amount here, the average, the actual mean in the full amount. $128,533.33 is the actual mean price of those 30 homes in New Jersey. Right? Standard deviation. What are we going to use? We use this function, stdev dot s. Why dot s? Because it's for sample standard deviation. Again, the same prices, B32 to B61 for New Jersey, multiplied by 1,000 just in this case, so I get the full dollar amount. All right. Critical value. Now, because there's no information at all about the population standard deviation, and we're dealing with means here, we have to use a inverse t instead of inverse normal. All right. And the function for an inverse t is t dot inv. Notice the area to the left is 0.97. Now, what am I asking for here is a 94% confidence interval. It's something different than the proportion question here. 94% in the middle means 3% on each end, each tail, right? That's the remaining 6. And the area to the left of the right positive value of that interval is going to be 94% in the middle, 3% on the left tail, 97%. That's why I use 0.97 here. What you use next is the degrees of freedom, and notice I point directly to H5, which is the sample size, and then I subtract 1. Sample size minus 1. Please do not put 29 in there. You get no credit for that. So please, you refer to the actual cells where these numbers are, right? Calculate the standard error. Well, the standard error is a little different for means, right? The standard error in general is the population standard deviation divided by the square root of the sample size. But because we don't know the population standard deviation, we're going to use the sample standard deviation in its place. And because we're doing that, we have to use we're using it's S instead of sigma, right? So instead of saying sigma divided by the square root of n is the standard error, we're going to use S divided by the square root of n. Where's S? It's right here in K10. So it's K10 divided by the square root of the sample size. Sample size again is in H5 right over here, 30. Notice I didn't put any numbers in here. I simply use formulas. And that's my standard error. Now calculate the margin of error. Okay. What's the margin of error? It's simply the critical value times the standard error. I multiply those two numbers, K18 times K21, and I get this $56,451.86 is my margin of error. Once again, to get my lower endpoint of the confidence interval, I take the sample mean way up here, $328,533, and subtract the margin of error. So it's going to be K5 minus K24 is my lower endpoint. And then the upper endpoint is going to be the sample mean plus the margin of error. Again, using formulas, not using numbers. Right? And then it says 95% confidence interval rounded to the nearest dollar. Right? Again, you do this in your head. All right. Each of these numbers here rounded to the nearest dollar. Well, none of them has 0.5 or larger as the decimal. So the answers are going to be 272,081 for our lower endpoint, and 384,985 on the upper. Right? So you do the rounding in your head. So that's how you do confidence intervals for both proportions and means. The next step is do hypothesis tests for both proportions and means. And again, use the same variable here, same variables. So for the proportion question, we're interested again in the proportion of homes that have that are priced at less than $500,000. Well, we know from our sample proportion about 80% of the homes in the sample are priced less than $500,000. However, we want to use this sample data to test to see if, in this particular case, if greater than 65% of the homes in New Jersey have prices less than $500,000. That's what we're testing, greater than 65%. Now, we ended up with 80% in our sample, but we have to do the test in the right way. And we're going to use an unusual alpha in this case, just using it just for illustration. I'm using a 3% alpha or 3% level of significance. Remember, the level of significance is the probability of a type 1. All right. Now, hypothesized population proportion. Well, that's going to be, in your null and alternative hypotheses, that proportion that you're going to see for the null is going to be P is equal to 0.65, because it says 0.65% here. So I'm going to use 0.65. And the alternative hypothesis is greater than, so we're going to use that alternative hypothesis will be P is greater than 0.65. So the hypothesized population proportion is going to be 0.65. All right. Level of significance, 0.03. It says 3% here, and you're going to change it to 0.03, put the number in there. All right. So both of these numbers don't refer to any formulas. You actually type these in as decimals. All right. So those obviously have to be decimals. Test statistic. Well, again, it's for proportions. So the test statistic will be a Z, test statistic. All right. Now, in the numerator, the numerator is going to be in parentheses. It's going to be the sample proportion minus the hypothesized proportion. All right. Hypothesized proportion. Now, what's a sample proportion? It's H14. That is what? That's this number right here. That's that 0.8. All right. That's our sample proportion. Let's go back to the test statistic. Minus N7. Well, N7 is going to be the 0.65. So we have 0.8 minus 0.65. But again, you don't type the numbers in. You refer to the cell positions. Make sure it's in parentheses. And then this denominator is going to be the square root. The square root, remember that? Square root. But in this, what's going to be inside the square root is the hypothesized proportion times 1 minus the hypothesized proportion divided by what? The sample size. All inside that square root. Okay? And where's the hypothesized proportion? It's in N7. That's right here. That's the 0.65. So it's 0.65 minus 1.65. Again, don't put 0.65 in here. And then it's divided by the sample size, which is, of course, in H5. Right, make sure it's the square root of all that. That's in the denominator. That's your standard error, by the way. That's what's in the denominator of this whole thing. And you get 1.7225 as your test statistic. Now this is a right tail test because we have greater than in the alternative hypothesis. It says greater than. Now it doesn't say alternative hypothesis, it says the claim, but assume that's the alternative hypothesis. And the alternative hypothesis is that P is greater than 0.65. So we're going to do a right tail test. So the p-value is going to be, if we draw a normal curve, we're going to look at the area to the right of the test statistic, right? And the area to the right of 1.7225 is going to be the p-value. How do we find that? Now we have to be very careful here with Excel. Now remember, in your calculator, we were able to do it in an easy way, but with this, with Excel, the area that when you find probabilities, the area, and they do have special functions for left tail, right tail, and middle, and all that. I don't want you to learn all this extra stuff. I'm just going to use norm dist for the area to find the probability. Right? That's like normal CDF. All right, we're going to use that. But notice I say 1 minus that. Why? Because this norm dist is going to find the area to the left of the test statistic, and remember, this is a right tail test. I'm interested in the area to the right. So I'm going to say 1 minus the area to the left is going to be the area to the right. All right, that's why I'm using 1 minus norm dist. Inside dist, N11 is going to be referring to what? It's going to be referring to the test statistic. All right, so that's what it's asking for there, the test statistic. 0, 1, that's the mean and standard deviation because it's a standard normal. Now, the thing that you have to include also at the very end is true. What is true referring to? And you have to put in capital letters. It's referring to whether we're using a CDF here. Remember, define probabilities with the normal distribution. We use normal CDF in our calculator. Yes, we want to use CDF, so we're going to say true to that. Remember, we have to type it in as capital letters with the true. Close parentheses, and we get our p-value, 0.042. Now, this last thing here is a interesting little function here, and I want you to use this. All right, unless you know Excel really well and you know how to do if statements. Many of you probably don't know how to do this, so please use this decision thing here. Now, because I have a level of significance listed here, and I have my p-value listed here, we know the decision is when the p-value is less than the level of significance, we reject the null hypothesis. Now, when we reject the null hypothesis, we are also supporting the alternative hypothesis. In other words, in this case, the alternative hypothesis is the claim. So in real life, you know, when we talk to people, we're not going to say, I'm rejecting the null hypothesis. You would say, there's enough evidence to support the claim, which is the alternative hypothesis. So hopefully that makes sense. When we reject the null, we are supporting the alternative or the claim. So what this is basically telling us to do here is, if N13, which is the p-value, is less than N9, which is what? The level of significance, I want to print out this statement here, enough evidence to support the claim. Okay? Otherwise, that's what the comma means here. Otherwise, I want it to print out not enough evidence to support claim. In other words, if the p-value is less than alpha, we're going to say enough evidence to support claim, or and another way of saying that is to reject the null hypothesis. If it is not less than alpha, if p-value is not less than alpha, greater than or equal to alpha, then I want printed out here not enough evidence to support the claim. Notice in this case, that's what it's printed out. Why? Because p-value 0.042 is greater than 0.03. It's greater than, which means we're not rejecting the null hypothesis. And another way of saying it is not enough evidence to support the claim. Okay? So please use this formula here. That's why I'm giving you this spreadsheet. This works nicely, and it should give you the correct answer. Look for hypothesis tests for means. Now, remember, when we did a confidence interval, we were interested in the mean price of homes in New Jersey. Okay, all homes in New Jersey. So the claim here is that the average home in New Jersey is less than $400,000. That's what 400K means. Use 1% alpha. So what does the hypothesized mean? It's 400,000. Now, you might ask here, by the way, well, how did I get the dollar sign in there with all the nice currency stuff in here when I just typed in, you can see up here, 400,000. And the way to do it is if you right-click that cell and go down the format, you could see there's an option for currency here. If you click it and you go with 2 decimal places, you can end up with what you're seeing, the dollar sign. All right. So I just made it look pretty. Level of significance, I put 0.01 here because it says use 1% alpha. Okay, I'll type that in. So I typed in the hypothesized mean, because in this case, the null hypothesis is that mu, the population mean, is equal to 400,000. And what is the alternative hypothesis? Well, it says is less than. So its mu is less than $400,000. Okay? So this is going to end up being a left tail test. All right. Now, test statistic. Because we are using sample data for the standard deviation, all right, and we don't have the population standard deviation, the test statistic will be a T, not a Z. The formula will look like this. In the numerator for the test statistic will be the sample mean, which happens to be where? In K5, that's the $328,533, minus the hypothesized mean in Q7, that's the 400,000. Okay. So we have the sample mean, $328,533 is K5 in K5, minus the hypothesized mean of 400,000, divided by, now we have to put the denominator in parentheses to make sure it calculates this correctly. In the denominator, we have a fraction, which is the standard error. Standard error has a numerator of what? The sample standard deviation. That is in what? K10, that's this $157,973, divided by the square root of the sample size. Remember, square root is SQRT. Where's the sample size? And that is in H5. That's right over here. That's a 30. Notice I did not put in any, let's go back to the test statistic. I didn't put in any numbers here. Referenced all of the positions in the spreadsheet. Notice the test statistic is negative. Well, that makes sense because the sample mean is less than the hypothesized mean. Now, p-value. This is a left tail test, and we have to use, if we were using a calculator, we would use TCDF, but in this case, we're going to use TDIST. There's a T dot DIST. That is the same thing as TCDF with our calculator. In parentheses, we want the area to the left. Now, this is a left tail test, so that's great. We don't have to do 1 minus here because the area is already to the left. All right, so that's what we're trying to find. The p-value is to the left. So what is the area in this case here? Well, the area is going to be, first of all, Q11, area to the left. Q11 is the test statistic. All right, that's what we're going to put in as the first thing here, because we are finding the area to the left. All right, that's what we're finding with TDIST. So the test statistic comes first. That's in Q11, that's the negative 2.4778, comma, degrees of freedom. Once again, sample size is an H5 minus 1. Now, once again, just like in the case of the normal, the normal distribution one, we had to type in true in capital letters because we want CDF here, a TCDF. So we have to type in true in capital letters. And here's our p-value, 0.00964. Now this is a 1% level of significance. Once again, we're using this exact same formula here, or the if statement here. Okay? If Q13, right, which is our p-value, is less than Q9, which is the level of significance, we're going to say enough evidence to support the claim. If it's not less than, the p-value is not less than the level of significance, we want to print out not enough evidence to support the claim. And in this case, because 0.00964 is less than 0.01, notice it prints out enough evidence to support the claim. All right. In other words, we are rejecting the null hypothesis and supporting the alternative hypothesis that on average, home prices in New Jersey are less than $400,000. There's enough evidence to support that. All right, now, what's the third option? Of course, in hypothesis test, we could have a two-tailed test. If it was a two-tailed test, obviously, we would calculate, depending on which one of these is, we have a proportion or a mean, we would calculate our test statistic in the same way. We would see if we're using the left tail or right tail, right? The difference is we have to multiply our answer by 2. So if this was, for example, if this was let's go to the hypothesis test for proportions. If the alternative hypothesis stated that the claim is that home prices that something other than 65% of homes in New Jersey have prices less than 500,000, something different than that, that would be a two-tailed test. And therefore, this formula here, we would just put parentheses around it and multiply it by 2 if it was a two-tailed test. And the same thing over here. If this is a left tail here that we ended up with. And again, if this was a two-tail situation, in other words, if the claim was that the average home price in New Jersey is different than 400,000, we would have put parentheses around this whole thing and multiplied it by 2. All right, so that's what we do if we have a two-tail test. All right, that's it. That's all for doing this, and I will post this along with this video, and then you can do your quiz. All right, so good luck with this. I cannot help with individual questions for this. The only questions I could possibly answer would be something like an interpretation of what I'm asking for, but I cannot give you hints or anything. You have to do this on your own, and I believe what I showed you here should be good enough for you to do this assignment and get a good grade. Remember, this is 15% of your total grade, so you have several days to do this. Please do not seek help. You need to do this on your own. You should not be copying somebody else's work, or actually, if you're the person who's doing the work and then you're giving it to somebody else to copy, bad idea. If I catch that, you both get zeros. So please don't do that. That's why I did the video. You should have enough information here to do this. It's a nice little skill to learn. The only way to learn it is do it on your own, and that's it. So anyway, I'm going to stop sharing, and let me just get this out of the way. And I wish you all the best, all of you. This is, I guess, the last time I'll see you before the final exam. So wish you all the best. Good luck. I know the situation's been difficult with COVID, and but I'm quite sure many of you will do quite well on this quiz, and hopefully do well on the final exam. All right, so good luck, and take care of yourself.